Hello! Today we're going to talk about how to factor a polynomial completely. So, basically when you guys factor, sometimes you can factor and think you're done, but you're actually not done. So after you factor, you look at whatever's left over in the problem and see if you can factor the remaining portion of the problem. And if so, which I hope so because we love to factor, guess what? You'll be factoring again. Okay, so we're going to be combining more than one of our factoring techniques into this problem, which the more factoring techniques, the better. So get pumped up. Okay, so the three factoring techniques we talked about, it's all about how many terms your polynomial has. So if your polynomial has two terms and the two terms are subtracting and are perfect squares, which means you can square root each term, guess what? That means you'll be factoring using a difference of two squares. If you have three terms and your highest exponent is a 2, which means you have a quadratic, if that is the case, you'll be factoring using general factoring, which the way I teach it to you is through slide and divide. And lastly, if you have 4 or more terms, you will be using group factoring. So it's all about how many terms you have. That is going to be the hint to let you know which technique to use. Because I'm not always going to tell you, well, factor using slide and divide. Factor using group factoring. Factor using a difference of two squares. Sometimes you will just have to look at a problem and just know right off the bat how to factor that thing. Something else to keep in mind. When we factor, you must always try to factor out the GCF first. Always. Okay, always look for the GCF first. If you can factor out the GCF, do that first. And then maybe after that, we'll be able to factor more. I don't know. We'll have to see. Also, something else to take note of, if you cannot factor a polynomial, so if you try real hard to factor but it's just not working out, that polynomial is called a prime polynomial. So just keep that in mind. Okay, so the first three examples we're going to do today, again, we're going to start by looking for a GCF. Okay, and then afterwards, if we spot a GCF, okay, we are going to continue factoring it using one of these nifty three techniques that I've taught you already. Okay, so looking at these example problems, since how many terms do all three of these example problems contain? Well, they all contain two terms. They are all subtracting, and maybe we'll be able to square root each term. I don't know. We'll have to see. So if that is the case, which factoring technique does it seem like we'll be using to solve? Holy hot dog. It would be a difference of two squares. So we're going to be using a difference of two squares on all three of these example problems, but first we're going to look for a GCF. Okay? Well, let's get going on the first example problem. All right, let's see if it'll work. Come on, thing. Come on, thing. Work. Sorry, guys, it is frozen currently. There we go. And my cat has joined us. Well, hello, Babette. She loves factoring. That's why she joined us. Come here. You silly kitty. Okay. Well, now let's get going. So, example 1, again, we're going to be factoring completely by a difference of two squares. But don't forget, we must always look for the GCF first. Okay, so I'm going to zoom in on example 1 and we can get started. Okay, so the first thing you must always look for in a problem is to see if there's a GCF. So before you try any other factoring technique, always look for a GCF first. Do you guys spot any GCFs in the problem? Well, let's take a look at the numbers first. So I'm going to label our GCF real quickly. Okay, is there a number that will divide into 4 and 16? Well, there's actually several numbers. What is the largest number that will divide into 4 and 16? It is 4. Okay, and since both of my terms do not contain an x, I cannot include x in my GCF. So guess what, you guys? My GCF is 4. So remember, we write the GCF out in front of the parenthesis, and then you're going to divide each term by the GCF. And we're going to write what we get inside the parenthesis. So let's see what happens. Okay, so I'm going to start by dividing the numbers. Okay, so 4 divided by 4, well, that will cancel and turn to 1. So I could write 1 here, but you don't have to. All right, and then the x squared, I don't have anything to divide that to, so I'm just going to bring on down my x squared. Okay, so you could leave it as x squared, or you could leave it as 1x squared. It's up to you. Okay, and then I'm going to divide negative 16 by 4. Negative 16 divided by 4 is a negative 4. So it'll be minus 4. Okay, so normally when we were solving before, after we factored out the GCF, we were done. We were like, yeah, we're done. But from now on, you have to look inside of your parenthesis after you factor out the GCF to see if you can keep factoring. So after you factor out the GCF, you must ask yourself, can I keep factoring? And we always hope we can because we love to factor. So I'm going to look in here now at the x squared minus 4. So I'm going to write x squared minus 4. Okay, so we already decided if you have two terms and you're subtracting and you have a perfect square, which I can square root x squared and 4, which is awesome, that means you can use a difference of squares. So from here, I'm going to factor what's left over using a difference of squares. And we're going to write what we get down here. Okay, so when we factor using a difference of squares, what you always do is you start by square rooting the first term and the last term. But don't forget, you never include the negative when we square root the last term. Okay, so I'm going to square root the first term, which is x squared. And then I'm going to square root the last term, which is, again, just the 4. We're not going to include the negative this time. Okay, so the square root of x squared, what times what gives you x squared? That would be just x to the first, or plain old x. And then the square root of 4, what times what gives you 4? Heavenly hamburger, you guys, that would be a 2. And then after you get done with that, all you do is one time you add your a and your c term, and one time you subtract them. So one time I'm going to add the x plus 2, so x plus 2. And one time I'm going to subtract them, so x minus 2. The only last thing that you can't forget about is after you factor the inside of your parenthesis, you must include your GCF in your answer. So I'm going to bring on down the GCF and put it right in front of my factored form. And after that, that is when your problem will be done. So just don't forget about your GCF. That is the part that most people forget. So don't forget about your GCF. Put that in the very front after you factor what's left over in your parenthesis. And that's it, everyone.